Hey guys, so in this problem we have a positive charge here in an electric field, and we're given a few initial values such as E equals 50,000 newtons per coulomb, the distance between these two, and the fact that here's x initial and v initial equals 0. And in this problem what we want to do is actually solve for the velocity final of when it reaches over there. So what we could kind of come from here is that delta K, which is the kinetic energy, plus delta U, which is the potential energy, equals 0 joules, because that's the law of conservation. So now that we have figured that out, we need to find out what delta K and delta U are. So the change in U is just U final minus U initial. And in this, we know that U initial is 0, and we see that this part, that'd be U naught plus 0 minus U naught plus QED. And once you actually distribute all that out, you just get delta U equals negative QED. And for our kinetic energy, same thing, it's K final minus K initial, and we know that K initial is actually just 0, so K final would just be 1/2 mv squared final. So now that we have this and we have this, we could just go with our delta K plus delta U equals 0. So our delta U was negative QED, and our K was 1 plus 1/2 mv squared. If you manipulate this around enough, we could solve for V by itself, which is what we're looking for. And once you do that, you have V equals the square root of 2QED over M. So we're given the distance, we're given electricity field, and we know that this is a 1.6 times 10 to the minus 19th, and we know that the weight of a proton is 1.67 times 10 to the negative 27th kilograms. So once we plug all of that in, our V will be 1.38 times 10 to the 5th meters per second. That's our answer. And that's all.